Okay, here's warm-up 6.6. Let's graph this exponential function. So good to know that an exponential function is always going to have a horizontal asymptote. I mean, it tells me in the question there. But it's going to have a horizontal line that it uses as a guide for the curve then, okay? So the way to find where to put that line is always what's added or subtracted to the end. So my horizontal asymptote is going to be the line y equals -4, because it would have to be y equals to give you a horizontal line. Okay, so there is my horizontal asymptote then. Okay, all right. So I'm looking at this, and since the base here is more than 1, that means I know I'm going to have a growth curve. So my graph is going to look something like this. Okay. All right, so now let's find the x and y intercepts to help us get an idea of where exactly we should put that growth curve in. All right, so to find the x-intercept, we're going to plug in 0 for y. So I'm going to write 0 equals 2 times 3 to the x minus 4. Okay, so let's solve this for x. So let's get x as isolated as we can with our old algebra techniques. I'll add 4 to both sides. Okay, we are going to put this in log form, but not yet. Let's first divide by 2. You can't, I sometimes see people rewrite this as 6 to the x. Well, you can't do that because the 2 is raised to the first, and the 3 is raised to the x. So you can't do that, but you can divide by 2. Now I've got 2 equals 3 to the x, and then I'm going to put this in log form. So in log form, my base is 3. Okay, the x is going to get isolated, and then the 2 is going to become the contents of the log, or the argument. Okay, and I'm going to put that into my calculator. So 3 raised to some power equals 2. Well, that's going to be some sort of a decimal, right? So I'm going to put that in my calculator using change of base formula. It's going to look like this. Okay, let's go ahead and put it in here. I'll put my calculator here. Let's see, log of 2. Don't forget to close the parentheses and divide by log of 3. And then we've got 0.63. Okay, so let's put that into the graph, 0.63. I can't get too accurate with that, but something like that, right? Just eyeballing about 0.6. Okay, and then for the y-intercept, we're going to plug in 0 for x. So that means I'm going to write this as y instead of f of x, because I'm going to be talking about a y-coordinate. And then this one's a lot easier to simplify. 3 to the 0th is 1. Anything to the 0th power is 1. And then I'm going to have 2 minus 4, so that's -2. Okay. And then I've got a pretty good guide right there for drawing my curve. So I'm going to have it approach the asymptote but never quite get there, and go through those 2 points, and I got my growth curve. Okay. All right, the rest of these problems we're going to be combining logs. So write as a single logarithm. Well, when you have the same base, you can combine logs. When we're adding logs of the same base, that means we're going to take the contents and multiply them together when we combine it. So this is going to be log base 3 of 2x times 4. 2x times 4 is 8x. And hey, it's combined into a single logarithm. Mission complete. Okay. If you've got a coefficient in front of any of the logs, like I do in this next problem, then you can't combine them even though they have the same base. But what we can do is use the power rule to rewrite these logs so that the 2 and the 3 will become exponents of the argument, exponent of the contents of the log, instead of coefficients. So this would be equivalent to log base 7 of x squared plus log base 7 of 5 to the third. And now we can combine those, okay, because we do have the same base and we don't have coefficients. So again, we're adding. That means we're going to be multiplying the contents. So I'm still going to have a base of 7, and I'm going to take x squared and multiply that by 5 to the third. Okay, 5 to the third is 125. So I can simplify this a little bit further. That would be 125 x squared. Okay. All right, again, we've got coefficients. So again, we want to use the power rule to move the 2 and the 3 out of the way. You could take the negative with this 3 if you wanted to, and then you'd be adding the two logs together. I always just pull the number itself and leave it as subtracting, but it'll actually work out either way. So this is log base 8 of x squared minus log base 8 of 4 to the third. Okay, now this is a little different because we're subtracting these logs, so that instead then of multiplying the contents together, I want to divide the contents. So this is going to, here, I'll write over here because I'm running out of space. So my contents then is going to be x squared divided by 4 to the third. Okay, 4 to the third is 64. But I usually write this as a fraction. And it is helpful to put in the parentheses when you got a fraction as the contents of the logs, just so it doesn't look like 864 is your base or something like that. Sometimes it can be hard to tell what the base is and what's supposed to be part of the contents of the log, part of the argument. Okay. All right. This last one, we're working opposite direction. So, you know, if you look at this, when we started out with two logs that were subtracted. So here we've got a fraction, so we should be able to break that into two logs that are subtracted. So I'm just thinking, oh, 5x divided by 9. So this would be log base 7 of 5x. And then since this is division here, I'm going to be subtracting. So, you know, division and subtraction go together. Multiplication and division go together in this context. And now I've broken that into two logs. Okay. Oh, you know what? We could actually expand this even further. I just noticed that because we do have two things that are multiplied together in there. So we could go even a step further. So I could take this log and think of that as log base 7 of 5 plus log base 7 of x, because when you multiply those together, that's what we get, right? So if we're expanding that all the way, this is a better answer. Yeah, so here, let me emphasize. Didn't quite finish it the first time. All right. Okay, that's the end of the warm-up, and I'll see you next time.